Hello everyone and welcome back to Anupam Tech Talk. In today's episode, we are going to talk about a very common problem when building APIs. How do we handle huge amount of data efficiently? Imagine an application that has 1 million products, customers, transactions or messages. Should our API send all 1 million records to the mobile application? Obviously, that's not good idea. And that's where API pagination becomes extremely useful. So today, let's understand what pagination is, how it works, and the difference between offset and cursor-based pagination. Let's start with simple example. Imagine we have e-commerce application with 1 million products. Now, the mobile application opens the product listings screen. If we simply call the API and return all 1 million products, we have a serious problem. The response could be extremely large. It could consume more network bandwidth, require more processing or server, and could also consume a lot of memory on the mobile device. And most importantly, the user does not need 1 million products at once. They may only see 20 or 30 products on the screen. So instead of sending everything, we need a better approach. The solution is called pagination. Pagination means splitting a large result set into smaller manageable chunks. Instead of returning 1 million products, we might return 20 products at a time. The first request gives us the first 20 products. When the user wants more, we request next 20. And we continue this process as the user scroll through the application. This reduces the amount of data transferred at any one time and makes the application much more efficient. One common approach is page-based pagination. We can send parameters such as page number and the number of records we want per page. For example, this request asks for page number 3 with 20 records per page. This approach is simple and easy to understand. It's commonly used in data, dashboard, admin applications, reports, and situations where users actually want to navigate between pages. But when data set becomes very large or the underlying data changes frequently, we need to think about another approach. Now, let's look at two important approaches, offset pagination and cursor pagination. With offset pagination, we tell the database how many records to skip and how many records we want. For example, an offset of 40 means we skip the first 40 records and return the next 20. It's simple but very large. Offset can become inefficient depending on the database and query. There is also another problem. If records are added or removed while we are navigating through pages, we can potentially see duplicate records or miss some records. Now let's talk about cursor-based pagination. So cursor pagination works differently. Instead of saying skip 40 records, we provide a cursor representing a position in the result set. Cursor-based pagination is particularly useful for large data set and continuously changing data, such as social media feeds or activity streams. Let's make Cursor way, let's make cursor pagination a little more concrete. The client makes the first request asking 20 products. The server returns those 20 products and also provide something called next cursor. The client stores that cursor. When the user wants more product, the client sends the cursor back to server. The server can then continue from that position and returns the next set of products. The response can also tell whether more data is available using something like has more flag. This pattern is very common in modern APIs. From a mobile application perspective, pagination is particularly useful. Imagine we are displaying a list of products. We initiated download only 20 products. The user sees those products on the screen. When user scroll towards the bottom, the application can request next page. This is often called load more or infinite scrolling. The important point is that we are loading data progressively instead of downloading everything upfront. This can reduce memory usage and make the application feel much faster to the users. But pagination also has some challenges. One common problem is getting duplicate records or missing records when the underlying data changes between requests. Another problem is allowing the client to request an extremely large page size. For example, if the API allow a client to request 1 million records in the single request, we have defeated the whole purpose of pagination. Very large offset can also become expensive depending on the database. And one of the most important thing is stable ordering. We need a deterministic way to decide which records come before another record. Otherwise, records can move between pages and create inconsistent results. So, how should we design pagination properly? First, define a sensible default page size, for example, 20 or 50 records. Second, do not allow client to request unlimited amount of data. The server should enforce a maximum page size. Third, make it clear whether more data is available. With cursor pagination, returning a next cursor is a common approach. Fourth, always use stable ordering. And finally, choose the pagination strategy based on the actual use case. We do not have to use cursor pagination everywhere. Page-based pagination or offset pagination can be perfectly fine for many applications. The important thing is to understand the data, the query, and the user experience. Let's quickly summarize today's episode. First, pagination prevents API from returning huge amount of data at once. Second, smaller responses reduce the amount of work required by the server, network, and the client. Third, offset pagination is simple and works very well for many use cases. Fourth, cursor pagination can be better choice for large data set or frequently changing data. And finally, good pagination requires stable ordering and sensible limit. The key idea is very simple. Do not send everything when the client only needs a small page of data, small part of data. And that's it for today's episode. API pagination may sound like a small implementation detail, but it becomes extremely important. when our application start dealing with large amount of data. As engineers, we should always think about how much data we are transferring, how frequently we are transferring it, and whether the client really need everything at once. And I will leave you with the today's thought. Good APIs do not just return data, they return the right amount of data. If you found this episode useful, please like the video, subscribe to Anupam Tech Talk, and share it with someone who might find this helpful. I'll see you in the next episode where we will continue exploring practical engineering concepts. Thank you.